Good morning. Welcome to our new webinar series on extreme events and hazards. I am Margaret Boone, Program Manager with the Southern Climate Impacts Planning Program, SCIPP, and I will be the moderator for today's webinar. Rachel Riley, SCIPP Associate Program Manager, will be managing the webinar. This webinar will be the first in a series of quarterly webinars that will focus on extreme climate and weather events and hazards that affect the southern United States. Since the hurricane season officially started on June 1st, the most logical focus topic for our first webinar is hurricanes. Today's webinar will feature a current update and outlook of the 2012 hurricane season by Victor Murphy, meteorologist with the National Weather Service Southern Region, an introduction and discussion to SurgeStat, the world's most comprehensive tropical storm surge database, by Dr. Barry Keim, Louisiana State Climatologist, and Hal Needham, SCIPP Research Associate, and a review of FEMA Hurricane Evacuation Studies and Hurricane Liaison Team operations by Rebecca Jennings, Hurricane Program Specialist with the FEMA Region IV in Atlanta. I'd like to briefly discuss the goals of this webinar series. We plan this in order to provide timely and relevant preparation and mitigation information to our local, state, and regional organizations, agencies, and business officials who are directly affected by these various extreme events and hazards. Each webinar will include an assessment of current conditions and outlook, preparations and plannings related to the hazard, and products and information useful for monitoring the hazard. We want to assure you that this information is seasonally relevant. Since this is a quarterly webinar series, our next webinar will be planned for sometime this fall. You may ask questions or make comments at any time through typing in your chat box. We will address questions at the end of the presentations. We will also put up a list of resources at the end of the presentation. I will now turn it over to Victor Murphy for an update and outlook of the 2012 hurricane season. Victor?
Hi, Margaret. Thank you. You can switch to the next slide. I'm Victor Murphy. I'm the Climate Service Program Manager with the National Weather Service Southern Region Headquarters in Fort Worth, Texas. And thank you for joining, everyone. You go to the next slide, and I'll be available for questions either when I'm finishing my presentation or else at the end. I'll be available either way. In general, the NOAA has been issuing the seasonal hurricane outlooks for about 10 years or so now. And the reason we do this is because bottom line is there is some skill there, and the skill is improving with time as models get better. And also, it does have a large impact with regard to risk mitigation, adaptation, insurance strategies, and things like that. The information we're going to show here is pretty much off our first forecast, which is done by a team of forecasters at the Climate Prediction Center in Washington, D.C., as well as some folks at the National Hurricane Center down in Miami. It was done the last week of May. The next update will be 2 weeks from today on August 9th. Don't anticipate any significant changes, quite honestly. Update off what I'm going to brief right now. So next slide, Margaret. Some of the features that go into the outlook, and I'll touch upon these. Main thing I want to emphasize is that we forecast for expected overall activity in the Atlantic Basin, number of named storms, as well as the cyclone energy index, which is a way of measuring, say, the number of storms times how big of an area they cover, times how strong the winds are. But the main thing to keep in mind is that the forecast does not imply activity for any one particular area or region, and all it takes is one storm in your given area to obviously give you very, very significant impacts. For example, look no further than Hurricane Andrew back in 1992. Obviously, that was the 8th storm and the first named storm of the year. It occurred, I think, was August 20th or so, very late in the season, and obviously had devastating impacts to South Florida, and then also, maybe about a week later, hit Louisiana rather strongly. So, once again, you must always prepare for that one storm, and people never need to, even though the overall activity might be less than normal, all it takes is one storm to severely impact you if you're a decision maker in a coastal location. But anyway, as far as the forecast goes, the forecasts are done based on an analysis and prediction of various oceanic and atmospheric climate factors during the peak months of the season. The timing of this call is very fortuitous because we have not reached our peak yet. The peak starts ramping up during August, peaks out in early September, and then it starts tapering off by late September. So next 8 weeks or so will be pretty much the peak of the season. Next slide. Starters, this year has been sort of unusual in that we had 4 named storms prior to late June. These are the tracks of these various different storms. We've got 4 named storms, one of which was a hurricane. The storm out there, the one out there in the middle of the Atlantic Ocean was Chris. That was the hurricane. The other 3 were just pretty much sort of frontal systems, etc., that sort of diminished, decayed, and sort of wallowed around in place, ended up getting some tropical characteristics and became named tropical storms. The only one of any note would probably be Debbie, which occurred from June 23rd to June 27th, and that's the 4th one there. It developed just east of Jacksonville, tracked westward, made landfall, if you will, near Jacksonville, tracked westward to about Tallahassee, and then sort of lifted off the northeast. It did bring a lot of rainfall, up to 15, 18 inches of rainfall to parts of North Florida, southeast Georgia, but all in all, that rainfall was pretty beneficial. There was some river flooding, but all in all, that rainfall was pretty beneficial. Both northern Florida and southeast Georgia were in pretty significant drought at the time, and I would say probably the cumulative benefits of Debbie probably outweighed the negative impacts due to the heavy rainfall in an area that needed the rainfall. So anyway, those 4 named storms aside, as you can see, the last one ended on June 27th. We've had no activity for the last month or so, which is not too uncommon this time of year. On average, the second named storm of the season doesn't occur until August 1st. So here we are on July 26th. On the average year, we'd have 1 named storm right now. The second one would be August 1st. Obviously, we're ahead of the game right now from that perspective, but the impacts, as far as any kind of accumulated cyclone energy index, et cetera, has been minimal. These have all been weak storms, not over a large area, and very minimal impact. Next slide, please. So with that behind us, here's what our forecast is calling for 2012. In the pink there on the right is our seasonal average, so the 30-year average from 1981 through 2010. In a typical year, we can expect to have 12 named storms, 6 hurricanes, and 3 major hurricanes. The forecast this year, which was issued in late May, and like I said, do not expect any significant changes, is calling for 9 to 15 named storms. The folks that know and make these forecasts do use a pretty significant spread in the number of storms. They have a 70% probability of the number of storms being within that spread. Just take the average number of those, between 9 and 15, average is 12. So pretty much, 12, perhaps maybe say 12 named storms if you had to pin down one number. As far as number of hurricanes, 4 to 8, same thing there. Take the midpoint, it would be about 6. Number of major hurricanes, 1 to 3, and take the midpoint there, that would be 2. So looks like our forecast in general is calling for maybe 12, 6, and 2. You can see the range of numbers there. So all in all, despite the early start, despite the fact we have 4 named storms, we're still pretty confident that when it all shakes out, we'll have a near normal season as far as overall activity goes. The pie chart there on the left-hand side, you can see we're calling for a 50% chance of near normal and about a 25% chance of either below normal or above normal. Factors that go into this, and I'll touch upon these here. Number one, we're in a period of, the Atlantic Basin at least, is in a period or an era of high activity. The Atlantic Basin over the last 10 years or so has probably been one of the few basins in the world that's actually had an increase in tropical cyclone activity. Most of the other basins have actually been sort of below normal. So anyway, that is a plus as far as us having above normal activity. A couple negatives, though. Looks like the El Nino is developing on the Pacific Ocean. That tends to dampen the number of storms in the Atlantic Basin. And also the sea surface temperatures right now in the Atlantic Basin are pretty much near normal to slightly below normal, which is another dampening effect or dampening factor. So the way these things, weigh all these things together, at the end of the day, we think we'll probably be near normal. Next slide. Slides there, perhaps? Thank you. Here's a forecast. You can consider on the left-hand side, 2012, 9 to 15 named storms, 4 to 8 hurricanes, 1 to 3 major hurricanes. You can see how that compares to last year's forecast. Last year's forecast was 12 to 18. We had 19 named storms, actually. 6 to 10 hurricanes, we had 7, and then 3 to 6 major hurricanes, we had 4. So Comparing 1974 from last year to what we expect this year is a pretty significant decline, all things considered. Next slide, please. This slide here shows the periods of high activity, or if you want to call it the Atlantic Multidecadal Oscillation, or AMO. You look at the period there from 1950 through about 1970 or so. Using this chart here, the area in yellow would be near normal activity, and you can see the significant number of years there that had above normal activity from the 1950 through 1970. That would be an era of positive AMO, or the Atlantic Multidecadal Oscillation is above normal sea surface temperatures, etc. From 1970 through 95 or so is the low activity era. You can see during those 25 years, only 2 of those years had above normal activity. The vast majority of those years had below normal activity, and unfortunately, that's when a lot of our development and population influx to the coast occurred in that 1970 through 95 time period, which was really an anomalous lull, what you'd normally expect. And then since 1995, you can see things ramped back up again. So we are back in an era of high activity, and that started in 1995 and should last for about 20 to 25 years. So just in general, there's going to be a predisposition or a tendency for us to probably have above normal activity probably through about 2015 or through about 2020. These AMO cycles last about 20 to 25 years. So on the far right is our forecast for this year, and you can see all things considered, considering the fact that we are in this era of high Atlantic Ocean activity. You can see the forecast there, that red line. The bulk of it is in the near normal area. All things considered, considering the fact that we're in the AMO, a positive index of positive phase of the AMO, that near normal forecast is really sort of a little bit unusual. You know, there is a strong tendency for us to have high activity during this era. Next slide, please. These are the various parameters that go into the Atlantic Ocean tropical cyclones developing. The area there within that rectangle, that's the MDR, or main development region. That's where most significant storms develop. As you know, the 4 storms we've had so far this year, none of them have been in this main box here, the main belt of development. You typically get easterly waves that move westward off the coast of Africa into this rectangular area, and then they in turn develop out in that area and become, you know, the long-tracked, named storms that we're used to. Next slide, please. Now, a couple of things, like I said, to go into the forecast. Number one is the tropical multidecadal signal. We have been in active era since 1995, so that has a plus on our dashboard as far as high activity. But there's a couple of negatives. One is, like I said, the El Nino developing in the Pacific Ocean, and the second negative is the cooler sea surface temperatures in the tropical Atlantic Ocean. Next slide, please. This slide here shows the sea surface temperatures out in the Pacific Ocean. Actually, it's called the Nino 3.4 area. And when it's positive, we tend to have below normal activity in the Atlantic Basin. These would be El Nino events. You can see there in July of 2009, we were well above zero positive, and I think the activity pretty much shut off around September or mid-September in the Atlantic Basin. Last couple of years, you can see July of 2010, and then July of 11, we're near normal to actually colder than normal temps, which is La Nina. That's the opposite phenomenon. During those years, there tends to be above normal tropical cyclone activity in the Atlantic Basin. We saw that in 2010, 2011. And you can see the far right side of the graph there. That's where we're at right now. You can see sea surface temps in the Pacific Basin are above normal right now, which means El Nino is developing. And the good news from that fact is the fact that during El Nino events, the Atlantic Basin tends to have below normal tropical cyclones due to the fact there's more wind shear than usual, or increased wind shear. It usually winds at the lower levels, westerly winds aloft, and that wind shear tends to dampen or inhibit the number of storms and the intensity of the storms. So that's a positive. What's a negative as far as overall development goes, I think a positive for most of us that live along the coast. Next slide, please. This chart here shows the sea surface temperatures in the Pacific Ocean I was referring to. You can see the area of pinks there along the equator between 120 degrees west and about 150 to 160 degrees west. that's the area we're looking at as far as El Nino or La Nina goes. You can see sea surface temps out there are on the average about 0.5 to maybe perhaps 1 degree Celsius warmer than normal. That would be a weak El Nino, so it's already in effect out there. Forecast to strengthen a little bit. Next slide. So it's forecast to strengthen a little bit, and that should inhibit the activity. This chart here, or this graph here, shows the sea surface temperatures right now in the Atlantic Basin. And if you look in there, maybe between 10 degrees north and 20 degrees north, you can see temperatures are pretty much near normal, maybe slightly above normal. But once again, nothing all that dramatic. Last couple of 3 years, we've seen sea surface temps out there 1 to 2 degrees Celsius warmer than normal, perhaps even up to 3 degrees Celsius warmer than normal. You can see there is a big band there of above normal temps off the east coast of the U.S. And over east of Nova Scotia, but of course that's not really an area that we concern ourselves too much. That's probably just due to the extremely warm summer and extremely warm spring we've had so far this year. Next slide, please. Okay, I'll let Barry perhaps talk about this more, but this graph here shows the climatology of named storms in the Atlantic Basin. And if you go from left to right, you see on August 1st, which is about where we're at right now, tend to have maybe, looks like about maybe 20 storms per 100 years, or maybe say 2 out of 10 years you have a named storm on August 1st. We probably won't have one this year, but you can see how it ramps up pretty dramatically. So the climatological peak is September 10th. In general, 9 years out of 10, you can count on having a named storm in the Atlantic Basin on September 10th. And you can see how it ramps down after that. So, as mentioned earlier, we just now are entering into the peak of the season, so the timing of this call is very fortuitous. Next slide. This slide here shows the development of the El Nino. You can see that the graph on the right-hand side is forecast for sea surface temps in the Pacific Ocean. You can see that sea surface temperatures are forecast to stay anywhere from plus 0.5 to perhaps plus 1 degree Celsius, starting where we're at right now in August and continuing through OND, which is October, November, December, and continuing through NDJ, which is November, December, January. So the El Nino, which is developing right now, should stay in place through the end of the year and should be a negative inhibiting factor on the number of storms in the Atlantic Basin 2 or 3 months in time. Go ahead, next slide. Getting closer to home here, as far as hurricane landfalls goes during near normal season, which is what we're predicting, the Atlantic coast, there's a 50% probability of a hurricane striking the Atlantic coast during near normal year, about the same as the Gulf of Mexico. Interesting factoid, though, is the fact that the Gulf Coast has slightly higher probability of multiple hurricane landfalls during near normal seasons. You can see during the near normal seasons, probably of 2 or more named hurricanes striking the Atlantic Basin is about maybe 10%, whereas Gulf of Mexico has about 20% probability. Basically, what we're looking at right now with the near normal season in the forecast, perhaps a 20% chance of 2 or more named storms in the Gulf, say a 60% chance of 1 or more hurricane, I should say, in the Gulf of Mexico. Next slide. In summary, we're expecting a near normal season due to the fact that the El Nino conditions are developing. That's a negative on the overall equation. We have near normal sea surface temperatures as opposed to what we've had in the past. That's another somewhat slight negative. But those 2 negatives are going up against the fact that we are in this positive peak period of the Atlantic multi-decadal oscillation. So in general, there's about a 60% probability of a hurricane landfall during near normal season for the Gulf Coast and about a 20% probability of getting 2 or more. And I believe that's it. Margaret, next slide. There you go. So I'm available for questions either right now or when we're done.
Thank you, Victor, for that outlook and update. I'd like to now introduce Rebecca Jennings, Hurricane Program Specialist with FEMA Region IV in Atlanta. Rebecca?
Yes, thank you. As they mentioned, I am Rebecca Jennings from FEMA Region IV, and I am going to bridge a little bit of what Victor said and then be a nice bridge, I think, into what our next presenters are going to discuss, because I'm going to talk about a little bit What we do in FEMA's National Hurricane Program, more specifically what we do in our region, and also about the Hurricane Liaison Team, and some of our operational activities along with that. So if you go to the next slide. So in Region 4, you may not be familiar with how our regions are broken up in FEMA, so there's a little graphic there in the corner. We cover basically the coastline from North Carolina southward to Florida and on over in the Gulf to Mississippi. Significant portion of our coast that has some vulnerability to hurricanes. And we are located within the Operational Planning Branch in the Response Division. We've been around since 1985, but a lot of our focus is on the tools, support, and technical assistance to our states and the local, partnering with them as they develop their hurricane evacuation plans. Our program as a whole is not just FEMA. We work very closely with many other partners. NOAA is a huge partner. We work very closely with the National Hurricane Center, National Weather Service, and a lot of our other support functions are big partners for us. The DOT, especially when we talk about things like evacuations. The Corps, they are big partners in the hurricane evacuation studies that we'll talk about, and numerous others. Red Cross, state and local agencies, and other groups. There's too many to go into. So it's a really comprehensive program, not just FEMA, and I think that we have one of the best jobs in FEMA because we get to interact very frequently with our state partners and the locals and provide them with very useful information. Go to the next slide. Our main areas of focus are on hurricane evacuation studies, HURREVAC, post-storm assessments, technical support, and a lot of that's through training and the HLT. If you click again, there's some graphics that may show up here. Here is a picture for you of just an example of some of the surge mapping that we do. That's part of our hurricane evacuation study process. And this really drives evacuations at the state and local levels, getting a true picture of what the risk is going to be. And again, for purposes of hurricane evacuations, we focus primarily on surge. That's where the greatest potential loss of life is. We say run from the water, hide from the wind. As a best practice. So we spend a lot of our resources looking at the surge vulnerability and then translating that into evacuation zones and clearance times. Look at again, another graphic will come up, HURREVAC. Many of you may be familiar with HURREVAC. It is our software tool that allows emergency managers to pull up the information from the National Hurricane Center as far as forecast details, and then marry that with the specific information from their hurricane evacuation study and a lot of the components from that study in terms of their transportation analysis and shelter analysis and vulnerability analysis, kind of in the background, so they can take a closer look at things like, if I call for an evacuation at noon, how long is it going to take to safely get everyone out? Or on the opposite side, when should I call for this evacuation based on the current forecast scenario? If you click again, another picture will come up. Click one more time. And this is an example of what we do in our post-storm assessments. And this is an example from the Florida storms, but we've done them most recently for Hurricane Irene in North Carolina, and it's ongoing for Hurricane Irene in New York, where we go back and take a look at what the emergency management community did during the hurricane, and when possible, I have looked at what the public did after a hurricane. And we get a lot of very interesting behavioral data from that, but also a lot of lessons learned from emergency managers as far as the value of some of the products and tools that we provide and how they use them during a hurricane. So our hurricane evacuation study components are first a hazards analysis, again just getting a true picture of what the hazards are, and then with a vulnerability map or analysis, mapping and cross-referencing that with some important information for that area. Could be critical facilities, could be nursing homes, could be whatever's determined by the local communities to be important information. Behavioral surveys, we partner with a variety of behavioral experts and social scientists who help us target communities and determine things like, will they or won't they evacuate? Where will they go? How many cars do they expect to take? All of that is very important to plan for how long the evacuation may take. It also looks at past behavior and a number of different elements to get an idea for the emergency managers of where they may need to focus their outreach efforts, or where people really do have a good sense for what their hazards are. Shelter studies, that's another key component for a lot of areas, looking at where the shelters are, especially where they are in relationship to some of their vulnerability and hazards, and how many shelters they have available versus their staffing capacity, and other things of that nature. Transportation analysis is really key. This is where we partner with our experts to look at the roadway network and how it will be impacted, and more importantly, how it will be filled during evacuation, where people are going to go, how clogged it may get, and they do modeling for scenarios that are selected by the local counties or communities to really be meaningful. Like, say it's Labor Day weekend and you've got passive visitors and people aren't familiar with hurricanes. How would you model a response on your roadways? So they can select that scenario in HURRAVAC when there's an actual storm, and very useful information in terms of an evacuation clearance time. And then the end product of all these studies is reports and maps that are hopefully useful tools for the emergency manager to have in their pocket operationally, but also for planning purposes, which is something that's going on. This kind of gives everyone from the locals and communities up through the state, at the FEMA level, and other partners, a picture of really the who, what, where, why, when, and how of hurricanes when you talk about planning. Next slide. As far as Region 4, we have new studies that are ongoing right now in Alabama and Mississippi, and those are wrapping up. Georgia and South Carolina continues to be ongoing, and we are getting ready to kick off in North Carolina. We also, outside of our region here, Region 4, getting ready to begin New England and Puerto Rico. And valuable as these studies are, they can take some time to complete. So once they're done, we're already planning for when we do the next ones and how we keep the data fresh and the information current. Next slide. If you're interested in looking at these studies, once they have them completed, they're available online. The link is a little bit difficult to see, but I'll be happy to send it to anyone who's interested. This is our partner website from the Corps, and this website's very useful. You can pull up, click on any of the states and access historical study data, pull up the maps where they're available. You can pull up post-storm assessments where we have them, find HURRAVAC information. I think there might be some HURRAVAC training vignettes and a link to their more robust site. If you could go to the next slide. So I mentioned HURRAVAC. If you're not familiar with HURRAVAC, it's a software program that is free for the emergency management community, and it was actually started by a meteorologist in Charleston, and he continues to maintain the program for us today. But again, the purpose is it's not rocket science. It's not the latest whiz-bang Google, Apple, Microsoft product, but it's very simple, and the beauty of its simplicity allows the emergency manager to do a little bit of analysis using the cone of uncertainty and wind speed probability information, wind radii information, and really cross-reference it with their specific emergency management information for their community. So you can see things like I mentioned before, or you can look at how long your area might be under tropical storm force winds, or when tropical storm force winds might be slated to arrive, see how your probabilities are changing, things like that for briefing purposes. You go to the next slide. Again, it's just a one-stop shop. Some of the information in HURRAVAC, we have wind decay information. You can get all the latest forecast information. So you've got, of course, the storm information, the cones, watches, warnings, wind timing. We also have QPF in there, which is quantitative precipitation forecast. So we get the 1 to 3 day from the HPC. So that's nice that it's in there for everyone to use. You don't have to kind of multitask. You can get that there and cross-reference that with things like the cone or other evacuation information. We also get flood outlooks. River information is in there where we have gauges, which is nice. You get the observations and the forecasts. And it's nice because it provides a common operating picture. So when we are briefing or looking at something during a storm and someone asks you a question, you know, you're looking at the same information. You're not, you know, you'll hear during a storm sometimes some crazy questions, and it's like, did you get that from the Weather Channel? Okay, well, let's take a look at what's in HURRAVAC. And it just helps make sure you're speaking the same language. If you go to the next slide. Again, this is another example of a type of product that you can get out of HURRAVAC, and this is displaying rainfall. If you go to the next slide. Again, just more information specifically about rivers. This is always very useful. And this is in there year-round, too, not just for hurricane season. So where they're available, and it's not available everywhere, if you're a HURRAVAC user, you can access it. If you're not yet a HURRAVAC user, you can download HURRAVAC at hurravac.com and provide your email. As long as you have a .org or .gov, I think, you can get the program for free. Next slide. Thank you. And another big component of what I do, switching gears, is now that after we focus on these hurricane evacuation studies and all of that, we go out and we actually partner and do a lot of training. And the Hurricane Center and National Weather Service are our partners in a lot of that training, as well as the Corps. So we do a lot of training not just on HURRAVAC, obviously, as a software tool, but also hurricane basics and hurricane hazards and using your hurricane evacuation study for planning and readiness and preparedness. Some of you may have heard of our course that we offer at the National Hurricane Center. It's an introductory course. This 5-day course is a residency course in Miami in January, so it's a pretty popular course, and many of our students report that it's very informative. And then we have an online version of that, which is also quite comprehensive, and you have to take tests, and I'll tell you it's pretty hard. So, but I'd encourage you to take that. Again, I know that the link is a little difficult to see, but that's the common module for community hurricane preparedness. And then we have other topical courses. One of them is inland hurricane readiness that we do either at our state request or at various workshops and conferences. So the next slide. The third major component of what we do in the hurricane program is the Hurricane Liaison Team, and that's what I'll talk about for the remainder of my discussion here. And the HLT, really, the initial idea arose in the early 90s and successfully proven during 1995, if you'll remember, like focal, and then became formal in 1996 as the FEMA director requested to formalize the arrangement. And the picture there, you can Billy Wagner and Luxian and a few others there. We really have had a great partnership with the National Hurricane Center, and that's the cornerstone of this Hurricane Liaison Team is the relationship we have with them. If you go to the next slide, here's a flow chart showing you our kind of how the communication works. And we joke because this is not to scale. The HLT, we actually have a full-time person at the Hurricane Center, and we wish our office was that big, but it's not. But we do, mentioning that partnership, we have someone stationed at the Hurricane Center year-round. So when we do need to go operational during a potential threat to the U.S., the HLT can bring up a cadre of emergency managers and that come from either the region, which would be myself and our hurricane program manager, Brandon Belinsky, or one of the other regions, or we can bring in additional support in terms of National Weather Service or members of our reservist cadre. So our communication somewhat is outlined here. We work very closely with the FEMA NRCC, with constant communication with them, constant communication with the Regional Operations Center. In Region 4, we're very fortunate to have 2 meteorologists here, and so we can take turns at the HLT and then the other one in the RRCC. So we're leading up the effort here and sharing information as soon as it comes out from the Hurricane Center so we have the latest situational awareness. Then communicating back and forth with the states and the locals. Again, that critical information so the forecasters can forecast, and we that next step of analysis when people are asking questions like, when are tropical storm force winds going to arrive in my area? We have the expertise and the background of understanding their evacuation zones and understanding some of the complexities that they're dealing with, and can walk them through scenarios and contingencies, as well as provide analysis of that forecast information in what I say emergency manager speak, which isn't always the same language as meteorology. And we don't do our own forecasting, and we don't try to replace the role of the local offices. In fact, we are huge proponents of, especially at the state and local level, having that relationship with your local National Weather Service office. And we will often deploy an additional weather service person down to the HLT to help us coordinate that aspect with them. And that really provides for the more detailed information as far as hazards when we are in an operational capacity. We go to the next slide. One of our roles in terms of a broader audience is to facilitate conference calls, and I know that the bane of our existence during hurricane operations is conference calls, but you can get to the point where you're running at least a conference call an hour, if not more, and everyone wants a Hurricane Center person on that call. So a big part of our role down there is to facilitate the briefings, make sure that there's someone represented on the call from the Hurricane Center, and then directing issues of importance back to them. It's a two-way communication, and often we've been able to give them valuable questions from the field. The picture you see there, that was during Hurricane Irene, and that's Jamie Rome in the corner under the monitor, hiding in the wings, and Director Reed at the time giving a briefing to President Obama, and it was very interesting. He's sitting there next to Craig Fugate, and during the VTC, the monitor was empty, and we waited, and as soon as we saw some scurrying, everyone stood up on the VTC, and we saw the president walk in, and it was a very powerful moment. That was a very memorable moment for us on the HLT. If you go to the next slide. I just wanted to sort of summarize everything I do here, and what you'll see is all of the competing information on the HLT here that we get. Here it's from, what's the model say, to, oh, I saw this in the media on, you name it, AccuWeather, Weather Channel, Jeff Masters says this, and then the emergency manager looking at, okay, which slosh basin am I supposed to be using, and what's the storm doing, and here's my evacuation zones. All of this competing information out there, and there's a push for more information, and one of our jobs on the HLT is to help people sift through this information to really pick out the most important points and the details, such as wind speed probabilities, rainfall forecasts, focus on those hazards, and really focus on the particulars for their scenario and provide that consistent message during a potential threat. If you'll click one more time, I think the final slide is an evacuation zone, and that's the summary is we help translate all that information into this, which is the planning that's done year-round. And it's really done not by us, but at the local emergency management level, and our role is to really partner with them and support them and provide the tools and support they need to do their job in the time. That's all I have, and I think we're going to field questions at the end. So if you have any questions, feel free to type them in. I can answer the one that popped up very quickly about the NRCC and the RRCC. FEMA is well known for its acronyms, and I apologize, I should have been more clear, but the NRCC is our National Response Center in Washington, D.C. So that's our headquarters response center, and the RRCC would be the regional counterpart to that are in each of the regions. With that, I will take any questions at the end. Thank you.
Thank you so much, Rebecca. I think you provided a lot of very I'd like to now introduce Dr. Barry Keim, Louisiana State Climatologist, and Hal, and they were going to give some information on the Gulf Coast.
Thank Thank you, Margaret. I appreciate the introduction. We're mostly going to talk about storm surge, but I really want to just briefly talk some about the seasonality of storms and where we are in this current season. Give me the next slide. As usual, Victor Murphy's always about 2 steps ahead of me, so he already showed this. But the thing I really want to focus on is that mostly that pattern is driven by sea surface temperatures. And we think of June 1st as the start of hurricane season, but occasionally we even get storms before June 1st. So it's not some magical date when all of a sudden storms can start popping up. It's really this gradual increase as the sea surface temperatures are warming into the season. And it just so happens that sea surface temperatures max out around September the 10th in the breeding grounds, and then it's kind of all downhill from there. But September 10th is the actual peak of the season. So next slide. What I want to do is just walk you through month by month, showing you all the tracks, and this is from an extended period. It's 1886 through 2006. I do need to get these updated, but nevertheless, it still gives you a good mental imprint of how the season shapes up as we move through the season, through that seasonality. So here you can see in May, we have 15 named storms. They're obviously occurring more in the shallow areas of the Caribbean, right off the east coast of the United States, but we're not getting storms forming out of the depths of the Atlantic Ocean. Next slide. And pretty much holds true for June as well. We're still not getting storms forming over the depths of the Atlantic, but we're getting an uptick in the storms forming in the Caribbean, the Gulf, and along the immediate east coast in the month of June. Next. As we get into July, sea surface temperatures are obviously increasing. Now we're starting to track the storms much further, deeper, if you will, into the Atlantic Ocean. And in fact, we can track those storms, the origin of those storms. In many cases now, we're going all the way back to the African continent, forming just south of what we call the Cape Verde Islands. And we call those storms that form in that location Cape Verde hurricanes. Another thing I want to point out is that we have at this time of year, in July and in August, we have a huge dome of high pressure centered out in the middle of the Atlantic Ocean in this particular slide, and the storms are basically forced or steered, if you will, around that high pressure complex. And that's why you see what we call a classic parabolic curve. And with the position of that high pressure, it tells us a lot about whether storms get driven into the Gulf of Mexico or whether they move up the east coast. Next slide. Again, another big uptick. Now, we're getting into more of the core of the season in the month of August. Sea surface temperatures are continuing to increase. We have lots of Cape Verde hurricanes. In this particular case, the Bermuda High is still pretty stout during this particular month. And you can see just how crazy the tracks are. I mean, this is a very, very active time period, beginning, for the most part, around the middle part of August. It's really the latter half of August when you see the vast majority of these storms. Next slide. Here is the busiest month of the year, September, whereby the sea surface temperatures are reaching their climax around September the 10th. But one noticeable thing as we get into September is that Bermuda High complex begins to weaken as we get into the fall season, and the tracking pattern gets a little bit more irregular, and you can see more of those storms tracking across the middle part of the Atlantic Ocean. Next slide. Move into October. Sea surface temperatures begin to cool. The Bermuda High weakens even further. And at this particular time of year, obviously there's a downstep in the total number of storms, but the tracking pattern also shifts a little bit more towards the east. And at this time of year, we start seeing fewer storms making landfall, for example, in northeastern Mexico and Texas and even Louisiana for that matter. Next slide. Here we are moving into November. Again, sea surface temperatures dramatically cooling down. November is really not that active of a month. Notice the Gulf Coast is, very, very quiet, although we have had one storm since 2006 that made landfall right around Mobile, Alabama. And but nevertheless, once we get into the month of November, as far as I'm concerned, I mean, the season is virtually over in Louisiana, although we can't exactly say that, because you never know, and just like I said a couple of years ago, we had a pretty close scare, and so it certainly can happen, but the probability is very, very low, at least for us. Next slide. Then we move into December. We've actually had one or two December storms since '06. They're obviously very rare. We're outside of the window of hurricane season, and I believe it was in 2005, we actually had a storm that formed between Christmas and New Year's and actually spun out or over into the new year. So some crazy things can happen. So I just wanted to put that in some context, give you the concept of the move into the real teeth of the season, and that really ramps up as we get, I'd say, mid-August, ranging into the first or second week of October is the real window for the core of the season. So at this point, I'm going to go ahead and pass the baton off to Hal Needham, who's going to talk about some of the storm surge work that we have ongoing here at LSU.
Thanks, Barry, and thanks everyone for tuning in. So as far as storm surge work, I came here in 2008 to do a master's degree, and I was interested to study storm surge. And when I came, I talked to Dr. Keim about some projects, and we realized that there were a lot of storm surge data out there, but just they were never really brought together into one place. And so we were interested to bring those together into one database and then run analysis on these data. So we found these data were very scattered. We found over 28 federal government sources, including the U.S. Army Corps, National Hurricane Center, USGS, FEMA. A lot of agencies had data out there. It just wasn't really brought together. We also found a lot of books and academic publications had data, and then historic newspapers. We found in cases, especially some of the older storms in which we didn't have federal data or academic data, sometimes you'd find an anecdotal account in an old newspaper. And so we read a lot of newspaper pages there as well to bring this together. We call this database SurgeStat. We were able to find actually around 200 peak storm surge levels along the U.S. Gulf Coast from 1880 until the present. And so actually in the next slide, here's a top 10 list of storm surge heights along the U.S. Gulf Coast. And so actually Katrina and Camille were number 1 and 2. The peak surge levels for those were around 28 feet and 25 feet respectively. If you talk to some locals they'll say with wave heights, some of these levels exceeded over 30 feet. But that's a conservative estimate there. But both of those storm surges peaked in the same location, which is past Christian, Mississippi. We feel that as you look at this, the shallow water off the Mississippi coast really enhances some of these surge heights. Hurricane Carla came in 3rd place with a surge height of around 22 feet in 1961. The Galveston hurricane, which you may have heard of because it was the most disastrous natural hazard as far as fatality totals in U.S. history, that was around a 20-foot surge in 1900. Hurricanes Eloise and Labor Day hurricane come in at 5 and 6. They were both in Florida with elevations of around 18 feet or so. Hurricane Beulah in 1967 produced an 18-foot surge in South Padre Island, Texas. Ike actually, although it was only a Category 2 hurricane when it made landfall, produced a storm surge between 17 and 18 feet, we think, in Chambers County, Texas, just 4 years ago. And then looking back to 1915, we have the New Orleans hurricane, which produced a 17-foot surge. And Hurricane Wilma, actually, we recently updated to 5 meters or 16.4 feet in southwest Florida in 2005. So this is just a snapshot of a top 10 list. Again, we found about 200 events for the Gulf Coast. Next slide, please. So this is a map. Actually, we mapped out these storm surges as far as putting a circle in the location where we think the surge peaked, and the larger circles represent higher storm surges. And what we found was really the northern and western Gulf Coast seemed to have the most activity as far as number of storm surges and also the magnitude of these events. And also the Florida Keys had quite a few large events as well. But if you notice, really the west coast of Florida, we get a lot of hurricane hits there, but very often storms will cross from east to west, and so they're actually pushing offshore as they move off the west coast of Florida, and that tends to minimize the storm surge levels in that area. Doesn't mean we can't have a huge storm surge in Tampa Bay, but just we haven't seen that in the past 130 years or so. So really it tends to be more the northern and western Gulf Coast where we see the most vulnerability. Next slide, please. So actually we made these data available on the web at surge.srcc.lsu.edu. This is, if you go to that website, this is what you'll see. And actually, we've expanded the data set globally. So we found about 80 surge events in Australia. We've also found some in the South Pacific. The highest, actually, in the world generally occur in the Bay of Bengal, along the coast of India and Bangladesh, where sometimes storm surge levels can exceed 40 feet, actually. And then the east coast of Asia, we see occasional storm surges approach 20 feet, very similar to the U.S. East Coast in that regard. So you can actually zoom in on this map. You can click on a dot, and it will tell you where and when a storm surge peaked. Right now, the legend is in metric. We're going to put feet on there as well. But actually, if we can go to the next slide, you can zoom into the Gulf Coast, for example, and say you were curious what that orange dot is there on the South Louisiana coast. If you click on that, that'll tell you that was Hurricane Lily in 2002, and it'll give the height in metric and in feet as well. There was a peak storm surge of slightly over 12 feet at Crewboat Channel in South Louisiana. So on that website, you can click on events and see peak surges in a given area. Also on that website, if you look at the very top bar there, you'll see there's a blog. And this next slide actually shows you a little snapshot of a blog that we just updated when Tropical Storm Debbie was in the Gulf of Mexico. And so what we generally do on this blog is look at National Hurricane Center forecast, and we'll try to compare that forecast track and intensity to other storms that have happened in the past. We don't do any storm surge forecasting on this blog, but we will provide some context. So actually in this image, you can see there I found a track of Hurricane Bonnie in 1986 that also, kind of went from the Central Gulf over towards the Texas-Louisiana border area. We did have storm surge data on that storm, and so we'll provide some context saying, hey, this current storm track and intensity looks similar to maybe something that happened in 1941, and here's what happened storm surge-wise in that case. Again, we won't forecast, but we'll just provide a little context of similar storms that happened in the past. Next, please. So when we developed this data set, we were really interested to analyze it, to understand a little more about storm surge along the Gulf Coast. And one thing we did here was a study on return periods, or how often a storm surge level is repeated. And so on this graph, the horizontal axis is return period in years, which is on a logarithmic scale. And the vertical axis is the surge height, which is actually metric in this case. And we just took the storms from 1900 to present. So we found about 180 storms. And Hurricane Katrina was actually the highest surge event. So we plotted out on this graph each of the surge events. Katrina was the highest event in 130 years, so that becomes a 110-year event. And that surge elevation was around 8.5 meters, or around 28 feet. The blue dot closest to that is Hurricane Camille, and so on and so forth. We plotted each of these on the graph and ran a linear regression through them. On the next slide, you'll actually see what we estimate the return period heights. This is basin-wide for the entire Gulf Coast since 1900. So using that graph, we estimate that the 100-year storm surge is around 27 feet. And then you can look down to, on the very left column there, you have the return period in years. So, for example, the 10-year storm we estimate is over 16 feet, which is pretty impressive when you consider your typical Gulf Coast community might be about 4 feet above sea level. That's saying that on average, every 10 years, we should see a 16-foot storm surge, which would put about 12 feet of water into some Gulf Coast community. Again, this is basin-wide. This is just an estimate. It's just to give an idea of how frequently storm surge levels reoccur. Next slide, please. So that last study was basin-wide. However, once we did that, we travel around a lot, meet a lot of people, and we noticed, someone in Galveston, Texas might say, well, that's interesting that you have the whole Gulf-wide data, but what about Galveston, or what about South Padre Island, or Pensacola, Florida? And so what we did here was a clustering analysis. Each of the multicolored dots in this graph are one of those peak storm surges, and the black dots are cluster centers. This algorithm basically, it just minimizes some distance from each storm surge to its cluster center, and it breaks the Gulf Coast down into regions. We basically did a linear regression on the storm surges in each of those regions to get an estimate of return periods. And so on the next graph, actually, we'll see some different levels of storm surge. So basically, on the very bottom there, going horizontally, you'll see zones 1 through 10. So these are the 10 zones that we broke the Gulf Coast down into. And then the vertical bars represent the return period heights. The top of the bar is your 100-year storm surge level, and then we break it down to 50, 25, and 10. The heights are in metric there in the left, but hang on this next slide, we're going to go over to what the heights were if we convert them over to feet. So on this next slide, you'll see actually the two most vulnerable zones are zones 5 and zones 3. Zone 5 is really southeast Louisiana and Mississippi. We estimate there that the 100-year storm surge level is around 25 feet. Zone 3, which includes Galveston, Houston, over through southwest Louisiana, we estimate the 100-year storm surge level is slightly over 20 feet. So that means that on average, every 100 years, we expect to see a storm surge of at least that level in that zone. So really, also zone 6, Mobile over through Pensacola, is pretty high as well, almost 20 feet. So again, we see a lot of red are the most vulnerable areas, orange comes below red, and then yellow are the least vulnerable areas. And so really the northern and western Gulf Coast, we see these higher return periods compared to the west coast of Florida, where we might see a 100-year storm surge level of around maybe 11 or 12 feet. Again, it doesn't mean that we can't have a massive storm surge in Tampa Bay. We just haven't seen that in this 110-year study that we did. So next slide, please. Finally, one of the limitations of that past study that I was just showing you is that we're grouping together a whole area. For example, Galveston, Grand Isle, Louisiana was grouped in with the Mississippi coast. And so it's a generalization. So people really wanted more specific data of storm surge history in their area. And so a tool that we're building experimentally right now, basically, this is Hurricane Ike that you're looking at, and we've plotted out all of the storm surge observations for Ike. Red are the highest storm surge levels, followed by orange, and then yellow are the lowest storm surge levels. And so just for Ike, we have 400 observations here. These observations came from the National Hurricane Center, FEMA, and USGS. On the next slide, actually, you'll see what happens if you click on this map on a specific point, say around Chalmette in St. Bernard Parish. You'll see that the storm tide there was around 9 feet from Ike. Even though Ike made landfall in Texas and the peak storm surge was all the way over in Texas, much of the Louisiana coast was inundated by a substantial storm surge, even up to around 9 feet there in the New Orleans area. The next slide shows the same thing for Hurricane Katrina. So there's a map of peak water levels in Katrina. If you click on Shell Beach, Louisiana there, you see it was an 18.7-foot storm surge. So these are all observed surge levels. None of this is modeled. This actually happened. We use, again, all these data sources that we've brought together, and basically we're just trying to observe what happened from storm surges and basically inundations in the past. Next slide, please. So what this tool basically allows us to do is overlay all of these storm surges. We have about 150 inundation footprints along the Gulf Coast, and so we can overlay these and we can actually search for storm surge history by location. And so this, if I look at everything within 25 miles of the center of Lake Pontchartrain, I get a list of about 20 storm surge levels that have occurred in the past. And the next slide is the last one. Basically, it's a similar idea for Galveston. So some of these places with a long history of data, like Galveston or Pensacola, Florida, we have over 25 storm surge observations for those locations. So this provides a list of, I think, 28 storm surge levels that impacted the Galveston area, no matter where the hurricane made landfall or where the peak surge was. So in summary, really what we did here was we took an area where there weren't many data as far as storm surge. We developed really what we think is the world's most comprehensive storm surge data set. And we developed a global map and blog that's available publicly. So you can, again, click on the historic events and see what happened. You can look at the blog for historic context. And we're doing some analysis as far as storm surge return periods. And then finally, we're developing a tool here where we can see the entire footprint of inundation from storms and actually look for storm surge history by location. One last note, actually, this latest tool where we look by location and we look at the whole footprint, that's not available publicly yet. We're still developing this, and a lot of more storms need to be put into them. But if you're working on a project where you need surge data, we are interested to collaborate, so let us know. And we may need people eventually to test out this website as well and use it and give us feedback. So thank you again for your attention, and I think that's everything that we have here.
Thank you very much, Barry and Hal. And one quick question, Hal, that's come across was, on the 100-year storm events, does that equate to a 1% annual chance?
Yeah, that's a great question, and that's exactly what that means. That means you have a 1% chance of equaling or exceeding that storm surge level every year, which would mean in 100 years we would expect to see that level.
Great, thank you. Well, I just want to give thanks again to all of our speakers, Victor, Rebecca, Barry, and Hal, for all of the wonderful information they've presented today. We will now open it up if anybody else has any questions or comments that they would like to ask. And we'll also leave this list of resources up on the screen. All of our presentation materials today will be posted to our SCIPP website, which is listed. And a 2-page PDF summary will be prepared of all the material and posted early next week. We're also recording this webinar, and it will be posted hopefully by later this afternoon to our SCIPP YouTube page if you'd like to. And we'll also put a link to that on our SCIPP Facebook page. So we encourage you to continue to spread the word to make sure all of those that are dealing with the planning, preparation, and mitigation efforts of extreme are involved in this new series. Along our PDF summaries, our webinar announcements, or any other information linked on these various sites. Let's look and see if we have any more questions. Yes, that's a good point that was brought up, that the 1% annual change, 26% chance 26% chance or 1 in 4 chance.
Do they predict the El Nino? When is the expected peak for El Nino?
Okay, question for Victor. How far do you look out to predict El Nino? Is that what you're asking? How far would you look out outside of this year, or can you, for trends in El Nino?
Good question. There's no real skill in that beyond, say, more than, say, 6 to 9 months at most. We're fairly confident that we're already starting to see a weak El Nino take place in the formative stages right now. It should continue to strengthen slightly now through the end of the year. El Nino and La Nina events usually peak in December, January. About 90% of them, 95% of them peak in December, January. So this event should continue to slowly build. By that I mean waters in the sea surface temperature waters in the equatorial Pacific Ocean should continue to slowly but surely warm in the months ahead, which hopefully will keep a lid on or help keep a lid on the number of named storms in the Atlantic Basin. And the El Nino itself should peak in December, January, which of course is outside of the time period for the Atlantic Basin season. The season ends, I think, November 30th. So the El Nino itself should peak December, January, then it tends to wane during the spring. And then what happens next year, there is no skill there whatsoever. It's probably 33% chance of either El Nino, probably 50% chance of neutral, 25% La Nina, 25% El Nino.
Thank you, Victor.
Yeah.
Another question that's been asked is with the river forecast system that's the National Weather Service has, when, if ever, does this gauge system reflect anticipated surge or hurricane rain? And I don't know if Barry, Hal, or Rebecca, if any of you'd like.
Well, we have looked at some of the gauge data, and we do see a storm surge signal propagating up some of those rivers, so it is present. Although we haven't looked at enough of it to really answer your question with any great authority, other than to say yes, it does exist, and there are some limited records because not every river obviously has has gauges at least in a position somewhat upriver where we can actually capture that. But we have seen some evidence of that.
Also,
Yeah.
no one.
Oh, I'm sorry. Go ahead, Victor.
That wasn't me, it was someone else.
Oh, I was just going to add to what Barry said that it definitely depends on where the data points are. There's not a ton of data available. Our gauges are somewhat limited. Where there's gauges, you're going to be able to get a more detailed forecast. We work very closely with the Southeast River Forecast Center, Lower Mississippi River Forecast Center, Ohio River Forecast Center. Our region here, Region 4, cross-cuts a lot of different regions. But we work very closely with them, and in the past have even deployed them down to the HLT in Miami or to the RRCC, the Regional Operations Center, when needed to better understand how the hydrology modeling is working, because riverine flooding is a huge contributor to some of the inland flooding that we see from hurricanes, which is another devastating hazard potentially. So we do work with them. They do have in their hydro models, they account for rainfall, they account for the surge is not quite perfected yet. That's a little more complicated, but I know that the background is there in the model.
Margaret, one more thing to add. NOAA has a really nice site called NOAA Tides and Currents, which also provides tidal gauges, as well as, people may be more familiar with river gauges, but these would be more tidal gauges along the coast. And some of these gauges are updated as frequently as every 6 minutes. So during an actual event, someone can go in and actually look at a gauge close to an area of coast that they're interested in and actually see what the water levels are. I don't think that they forecast surge at those gauges, but it does give you an idea of the present water levels.
Well, one more complicating factor on these gauges that are somewhat upriver, near the coast but upriver, is that we also have rain events taking place within those drainage basins, which is also driving the levels of the river up. So sometimes it can be a little tricky to parse out the difference between the rainfall flooding, the river basin flooding versus the surge, moving in from the opposite direction.
Thank you. I think that was a very good answer to those questions. It doesn't look like there's any more questions for today. So again, thank you to all of our presenters, and thank you for the audience for participating today. And we look forward to continuing this conversation with you in the future. Thank you.